So now I have a character which is working with a Navmesh. However, I want this camera to be driven via entities rather than through a managed script. However, before we do that, I have a couple of errors that I want to deal with. These are not major errors because they do not affect the scene. These are essentially dots debugging errors. These are saying that I have a system that is running that is looking for a component, but that component is not currently being found in the scene. The first error is to do with my input. In this case, there's no entity with a tag input component, and my input script is looking for this. The second is my camera, as currently my camera isn't being set up for entities either. I can now look for the script. Some of the entity error messages are not always the easiest to read, as the script that is causing the error is not always listed first. The error will, however, be displayed at some point, and in this case the error is with my sysplayer input script. I can open the script to work on it. This script is a managed entity script, and it inherits from system base. I have performed a similar operation with an iSystem, but the setup for a system-based script will be slightly different, as this is working with a class and not with a struct. I'll be looking to generate an override for the script, and this will be an onCreate override, as I want this to occur before the scene is actually running. I'll reference the current class using this. This is purely to get the IntelliSense working, as I want to see which methods are available on the script, and what I'm looking for is a required for update method. Here I'll specify that we need a tag input in order for this system to run. This will prevent the first error from showing up, which will help us declutter the console a little bit. Next I have the error for the camera, and this will be very similar. This will be running on the system script for the player camera. Once again, we'll be overriding the onCreate method. The camera is going to be associated with the player, so I'll need to check if there is a player in the scene. And for this, I'm going to look for the tag player component. This will remove errors from my console. These errors are strictly related to my player and adding the player to the scene. If the player is functional in the scene, these errors would not occur. These errors are not a big deal, but they do clutter up the output console, which will make debugging things which are not related to the player rather difficult. Suppressing errors is not usually a good thing, but in this case I will do it. I can now continue working on the Navmesh setup, and I'm going to add two scripts to this project. The first will be a script, and this will be a system script, so I'll add a new iSystem script to the project. I'll call this script sysNavmesh. I may change this name later, but it'll be good enough for the moment. I'll then create a second script, and this script is going to be a Baker script. I'll call this authoring Navmesh agent. So I have two scripts which I'll be using for my agents. I'll need to use these within the scene, so I'll need to create an entity for this. And for the entity, I'm going to create a subscene. Under my subscene folder, I'll add a subscene, and this will be called sub Navmesh agent. I will add it to the existing scene so that I can transfer things from the existing scene to it. I'll remove the camera and the directional light from the subscene. I can save the changes to the subscene, and to make sure that the subscene is empty, I can enter it, and we'll see that we do not have any cameras or lights here anymore. I'll then return to the test scene. I'm going to want to add the Navmesh test object to the subscene, and I'll add the subnetwork to the scene again. Currently, the Navmesh test object is not being converted into an entity, and I'm not going to add it to the scene directly. Instead, I'm going to add it via an authoring script. So I'll add a new game object to my subscene, and I'll call this Navmesh agent. I'll then drag and drop my Navmesh test game object onto my prefabs, so this will now be a prefab and not a game object. This is going to be a managed entity, so I could prefix this with Geo, and I could call it Geo NPC. Once again, this is a temporary name and I may change this later. I'm now going to use this prefab within my Navmesh agent. To add this to the Navmesh agent, I want an authoring component, so I'm going to work on my authoring component for the Navmesh agent. First, we'll have the Navmesh agent class, and this will be a mono behavior. Here, I'll create a variable for the item which we're going to add. This will be a public game object, and for the moment, I'll call this prefab. Then in the baking class, I'll specify this as a component. I'll begin by getting my entity. This will have a type of entity, and I'll store this in the variable entity. Here, I'll use the getEntity method. This will take transform usage flags as an argument, and this is going to be a dynamic entity. I can then add this prefab to the entity, and because this is managed, I'm going to use an add component object method. The first argument will be our entity. I'll then be adding my game object. This will be a new component, but I haven't really created a component for my Navmesh agent yet. So I will add this to my component game object script. Essentially, this will be the same as the game object prefab, and we could actually use this game object prefab, but for the moment, I'm going to keep all of these operations separate. This will be a public class, and it'll be called game object NPC. It will be inheriting from iComponent data, and it will contain a public game object which will be called prefab. I can then add this in the Baker script. So the second argument here will now be adding a new game object NPC. We'll initialize this between curly braces. This will be set with our prefab, and this will be set with our authoring class. And here we'll specify the prefab with .prefab. So essentially this will get the reference model behavior, and it will add it as a component on our entity. I can now add the authoring script to the Navmesh agent. And in the component, I'll specify my game object NPC as the prefab. This will set up my subscene. However, this will not do anything and it will not work. There are a number of reasons for this. The main one being that we haven't actually set up anything within the Navmesh system, and this means nothing will be performed. So I can work on the Navmesh system. Here I'll work on the onUpdate method. I'm going to work on the entity component buffer here. I'll store this in the variable name ECB. I'll set this using the system API class, using the getSingleton method. The type of the singleton will be begin fixed step simulation entity command buffer system dot singleton. I can then call the create command buffer method. The argument here will be state, and this will be a world unmanaged buffer. This will give us a buffer for commands which will run at the start of our loop. I haven't given it a type for my ECB variable. I'll set this automatically using var. I can then loop over my entities. So this will be for each, and our variables will be entity and prefab. I'll then get our entities using in system API.query. I'll be looking for any entity with a GeoNPC tag. I'll then call the with entity access method. This is what will set the entity variable and the NPC variable at the same time. I can now use these, and I'll start by instantiating an entity. This will have a game object variable, and I'll call the variable game object. I can then call game object.instantiate, and I'll instantiate my prefab with prefab.prefab, and this will make sure that my prefab is visible within the scene. I have made a mistake with my variable. Prefab should precede entity. I can then get my game prefab with prefab.prefab, and this is what will be instantiated within the scene. I can return to Unity to test this, as we should now be able to see the prefab within the scene. I'll delete my Navmesh agent from the scene, and I'll test, and nothing will happen. So this is not working, and the reason it's not working is because of my subscene. I am not actually adding the subscene to the scene. I do have both scenes open, as that allows me to work with them in the viewport, but the subscene is actually not currently part of the active scene. So I'll remove the subscene here, as I'm not actually wanting to add it as a scene, and instead I'll get a game object. I can then add the subscene component to the game object. Here I'll specify the Navmesh agent subscene. I can now test this, and I'm generating an entity, but I'm actually generating multiple entities, generating an individual NPC every single frame. This is not what we want to do, so we'll need to update this. So once I've finished my frame, I want to remove my component from the entity, because we currently are adding another entity with the same component every single frame, which is leading to the duplications. So I'll have the ECB buffer, and I'll call the remove component method on this. I'm going to remove the GeoNPC component, and I'll remove this from the current entity. I can now test again, and we're generating a single NPC. We no longer have any of the duplication issues. So now I'm instantiating my mesh. The next thing I want to do is get the Navmesh agent component from this, so we can use this to control our entity. I'll add the component to the component buffer with ECB.addComponent. The component is going to be game object component, so this will be geo, and it'll be our Navmesh agent. This is not a component that we have, so I'm going to need to create this within my components. This will be a managed component, so this will be public class geo Navmesh component. It will inherit from iComponent data. This will contain a public Navmesh agent, and I'll call this Navmesh agent. I can now add the game object component to my entity component buffer. I'll add this to my entity. I'll then specify this with a new game object Navmesh agent, and I'll initialize this between curly braces. The Navmesh agent member variable will be set with GameObject.getComponent in children. There should never be anything within our scene which will contain more than one Navmesh agent at the same time, so we'll assume that there will only ever be one Navmesh agent. The type of the component which we get in here should be Navmesh agent. The Navmesh agent should now be available within our entity component buffer, and we should now be able to use this. I can now loop over my entities again, and we'll say for each agent in systemapi.query, and here I'll be looking for anything with the game object Navmesh agent. I can now update the destination for the agent. This will be done on the Navmesh agent component, and it will use the setDestination method. Once again, I'm going to make a random destination. In this case, I'll say 12 in X and 4 in Z. This value will be a vector, so we'll need to create this as a new float3. To do this, I should also import the Unity mathematics library. I can now save this, and we should be able to test our Navmesh agent again. When I run the script, my agent is now moving, which is what I want. This is now working, but I want to test this a little bit more thoroughly. So I'm going to add some obstacles to the scene. We already have an existing obstacle with the cube. I'll duplicate this and I'll position this in between my character and his destination. And I'll do this a number of times. This isn't really a maze, but I do want to know if the character is going to move the opposite way from his final destination. I will need to rebake the Navmesh in order for these components to have an influence. I can now test, and the character is moving towards his destination. This means that my character is being driven by the entities to use the Navmesh. This is not the most efficient system, as using unmanaged Navmeshes are far more efficient, but I'm not working to see how many entities I can pack into a scene. Instead, I want you to work on an animation and AI system. The other systems are not yet built into entities, and this is far easier to implement. This will allow me to work on things which I need to in a practical manner. This is still fundamentally setting up a prototype, and I can worry about things like performance later if I ever move beyond that. So this will give me the start of the NPC system, and it will allow me to work on tying together the player and the NPC animation systems at the same time, which means that I should be able to start working on NPC logic now.